Hello, this is Doug Arnold. I'm going to talk to you about timing in the broadcast, finance, and data center industries. Here's our agenda. Before I get to those industries that I mentioned in the title, I'm going to talk about the need for packet timing in industry in general.
So virtually any industry that has some kind of distributed control system or communication system looks like this. They, in the past, had their own unique communication technology and unique timing technology, which is pretty much always some kind of signals on dedicated cabling and hardware. And they're all moving to standard datacom technology. And this is all driven by the cost you get from economies of scale. But where they're at now is some mixture of the past and future where they might have moved their network to a datacom network, for example, but they still have all these devices that require legacy timing signals. And these devices can often be quite costly to replace just for the timing upgrade. And so in the present, we typically have to support a mixture of the old and new. Time is needed in broadcast and media, basically to coordinate the activities of multiple cameras and multiple microphones that are capturing the content. This is especially true in live TV. The timing requirements are typically on about 10 milliseconds for video or mono audio. That's about half of a video frame. And 10 microseconds for high fidelity stereo audio. However, to meet the stereo audio requirement, typically just 1 microsecond is allocated for the error budget for network time distribution. There's a whole lot of legacy timing signals in the broadcast industry. For video, there's blackburst and tri-level sync. There's audio signals called word clock and the digital audio reference signal, or DARS. Together, these signals are referred to as genlock, and they all have on-time marks. Then there's linear time code, which doesn't have an on-time mark, but it has the information needed to insert a timestamp in a video frame or in an audio file.
The two most important standards organizations for time distribution in the broadcast industry is SMPTE, originally the Society of Motion Picture and Television Engineers, although that name sounds a little dated, so they're moving away from it and just calling themselves SMPTE, and the Audio Engineering Society. Both of these groups have devised a PTP profile. They're both layer 3 end-to-end, and in fact can work together. In the case of the SMPTE profile, they also have a special TLV that attaches to the announced message that has all kinds of timing metadata, including things relevant only to broadcast, like video frame rate and that sort of thing. In their terminology, they have replaced master-slave with leader-follower and retained grandmaster.
Next, we're going to talk about the finance industry. The finance industry IT professionals have an enterprise IT viewpoint. They think of the IETF as where standards come from. They are also comfortable with non-standard approaches, especially the high-frequency trading firms. They sometimes use non-standard NTP rather than PTP. There are laws that regulate their time accuracy, so that's obviously very important for them. They have to do it. They often need to get time at the software layer of standard server hardware. And if they're doing HFT, they might be implementing code instead on FPGAs that sit on PCIe cards. There are two kinds of timing requirements in finance. The first is regulatory compliance for trading. In the United States, that is in the consolidated audit trail, and it requires all transactions by traders to be timestamped to within 50 milliseconds of UTC NIST and to within 100 microseconds by exchanges. To trade in Europe, it would be the MiFID II standard, and that treats both traders and exchanges the same, that they have to be to within 100 microseconds of UTC. Now, since many firms do business all over the world, they would want to be compliant to the stricter MiFID II standard. And then lastly, especially for HFT firms, they want to measure their latencies in their system. This is not to do with the regulation. This is just to measure how well they're doing, because after all, they are in a race. And those times are much, much tighter, typically 1 to a few tens of nanoseconds.
Timing protocols in finance include default PTP profile, enterprise profile, which is defined in the IETF and includes a mixed multicast unicast operation, specialized NTP that has properties like high message rates, lucky packet filters, hardware timestamping, so more like PTP kind of things than you would see in just ordinary NTP, and high accuracy PTP, typically some implementation of the White Rabbit project, open source and open hardware project.
Now we're going to talk about timing in data centers.
Data centers, of course, are full of IT equipment, and so they need, setting of time to the order of milliseconds for log files and security key timeouts. But more recently, microsecond level timing has come in to synchronize distributed databases and make them more efficient. When the different copies of the database are synchronized, they can exchange fewer messages to keep the data harmonized, and they can also be more available with fewer blockout times while they're syncing to each other. This time synchronization today is typically about 10 microseconds, although that may go down in the future. Other distributed applications such as AI training or hyperscale computing would possibly want even tighter time synchronization capabilities, because they might be worrying about the latencies within the same data center. Now, cloud vendors are also looking to host infrastructure for finance and are in fact starting to do that. That means that they would have to be able to meet the CAT and MiFID II requirements previously discussed. Timing technology in data centers, it can be based around PTP or NTP. And the PTP, if they have that, it could be with or without on-pass support. NTP often includes leap seconds that are smeared. That is, rather than inserting an extra second, slow the clock down to account for that over some period of time, like 24 hours or 12 hours. There's no standard for that. It turns out it's easier or more efficient to mess up the time that way than actually get the database software to handle leap seconds. An important organization for the data center industry is the Open Compute Project, or OCP. It's an industry consortium. They share open software and hardware and best practices. And within that, there's something called OCP TAP, Time Appliance Project, which includes, among other things, an open time card design. There's a lot of interest in some kind of stateless client server PTP. So it works like NTP, but it can take advantage of on-pass support. And there is a project in IEEE 1588 working group called IEEE 1588.1 to define CSPTP. Thank you for listening. I hope you got the background information you need to understand presentations at the WSTS in these industries. If you have any further questions, don't hesitate to email me. I love questions. And I look forward to seeing you in Bellevue, Washington in May.